Okay, so last time we left off with this idea of creating desirable difficulties during the learning process itself, as opposed to retrieval. And we introduced the idea of blocking or mass study. And so when people have several things to learn, they often practice one thing and then another and then another. And the example for tennis was first we'll drill our backhands and the forehands and overheads. Well, the same kind of thing can happen in the academic world as well. So we might practice one type of math problem and then go on to another one, or one type of physics problem and then do another one, or chemistry problem, or whatever. So that would be mass study. The other approach to this, Bjork argues, what he calls interleaving, can be illustrated in this type of in a study that was done with painters. So the subjects attempted to learn the styles of 12 different painters. Now, for some of the painters, they were studying the information in the block condition, so mass study. So they would study 6 paintings for the first painter, then 6 paintings for the next painter, and so on. But they would also, for other painters, be set up in an interleaved condition, so where the paintings would be mixed up. So they might get a painting from painter number 8, and then the next painting is from painter number 11, and the next painting is from painter number 7, etc. All right, so that's the interleaved condition. So the blocking is when you get all 6 paintings from one painter, and then the next painter's paintings, and so on. And the interleaved is when they're all mixed up. Now, if you ask the people during the training, so most say that blocking helps them learn better. However, the interleaved groups showed better long-term retention. They were able to remember the styles of the painters and also categorize new paintings better than those who were studying in the block condition. Now, what would that look like? So here's a painting. It's a Dali. Here's a Picasso. And again, if you're in the interleaved group, you would have these paintings presented from different painters all mixed up. Whereas if you were in the blocked group, you'd have the Kandinsky paintings all presented to you in sequence. Well, here's some data from that experiment. So the left panel shows the proportion of participants who selected blocked, interleaved, or the same in response to this question. Under which condition do you believe you learned better? Most said that they learned better under the blocked condition, where they were getting all 6 paintings for each painter. The right panel indicates the proportion of participants who actually perform better in the blocked or the interleaved conditions, or performed the same in the 2 conditions. So some performed better in the block condition, some it was kind of the same, but many performed better in the interleaved condition. So notice the disconnect between the experience of the training and the actual performance. So during blocking, it may be that students take fluency as the measure of learning, right? So they get the style of the painter. The interleaving of painters is more of a struggle. But what may be happening, though, is that students may be mistakenly inferring the quality of their learning from the experience of the training itself. So you see, if one perceives that they're learning better under the blocked condition, right, that may be a misperception. It may seem that you're learning the styles better, but that may be a short-term effect. What could be better for the long term is the struggle of doing the interleaving process. So again, another example of how our own perceptions of the learning process may be in error. Right? We may think we're learning better under the blocking condition when in fact interleaving would lead to better results. So why does interleaving work? Well, Bjork has some possibilities. It forces attention to similarities and differences across trials, and then you have to sort of always reload, the retrieval processes for each different painter each time a new one comes along. Right? You have to reaccess that new painter, and that may be beneficial for long-term retention. So to summarize, Bjork is arguing that we might have some misconceptions about the learning process. What is it that best allows us to increase the storage strength, and so keep information for long intervals of time. When we're rehearsing information, we have high retrieval strength, but we're in jeopardy of mistaking that high retrieval strength for subsequent storage strength. And so this is one misconception. Another is that we may not be properly assigning value to tests. They're not just assessment devices, but they actually can be useful learning tools because they force retrieval. Retrieval is good for increasing storage strength. The delay idea that yes, we might know that spacing out study sessions is theoretically a good idea, but we don't practice it. And this this idea that forgetting is a friend of learning can seem sort of counterintuitive. In fact, there's some evidence that students underpredict how much forgetting will happen. In other words, there tends to be this notion, what he calls a stability bias, that we think that what we've got in our minds at the moment is going to stay there, right? So we don't really take into account that forgetting is going to happen. But that can be a good thing, because then if we do another study after some delay, that will actually help cause a spike in the storage strength. So as students, we go about the business of trying to learn stuff, but we might have some misconceptions that are obstacles to our own learning. And this is the whole point of his research and his lab, is to uncover the human memory system, the learning and memory system, and then to try and draw useful lessons from that for students and teachers as well.